Artificial intelligence offers a lot of chances for microcontrollers. As always, around this time of the year, I will look at this topic from a broader angle to see the implications of this technology on our hobby and professional lives. It extends the video on rules and shows how they are interwoven with artificial intelligence. As usual, I will stick to the implications on sensors and microcontrollers. And I hope you will get some useful insights for your decisions in 2025. And the project I will build will be for the cat, as we say in German. This video, as all others, is sponsored by my loyal Patreons. You deserve a special thank you, because you are a big motivation. Grüezi YouTubers, here is the guy with the Swiss accent, bringing you a new episode with fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. For my half-life, I helped big companies implement software for logistics, finance, and human resources. There I learned a lot about how to deal with rules, who makes them, and how to distinguish between good and bullshit rules, as shown in video number 412. Today I will show how we can use this knowledge to deal with AI. First, we all know that these systems are not intelligent in the human sense. Their pattern recognition is much more related to rules, even if they can provide very good and sometimes unexpected answers. Let's dive a bit deeper to understand how things fit together and how we can use rules and AI to our advantage. Humans have always used rules to organize their lives and society. There are ethical, religious, legal, or practical rules. Physical laws are another essential set of rules and are part of practical rules. They are only found by humans, and most engineers know that they cannot be changed, just adjusted with more knowledge. Moral, religious, or legal rules, on the other hand, are usually created by humans, sometimes maybe by gods. But they can be adapted if we want. An essential difference. Most important for AI are the rules of thumb. These are practical rules learned from the past. I think they are a good example if we want to understand AI. They are not perfect and sometimes even false, but they make our lives much easier. Calculators or algorithms are better suited for formulas than pattern recognition. At least they will be faster and less power hungry. So we found three sets: rules that are created, rules that are discovered, and formulas as a special case. AI's current domain is discover rules. Later we will see why. And this is why AI systems have two distinct phases: training and inference or execution. During training they learn something we could call rules based on many examples, and during inference they use the learned content to give answers or decide. We could also say that they execute learned rules. This is why the first AI systems were called expert systems, by the way. Modern AI is way more complex. Still, it should stick to finding rules. If it creates them, we call it hallucination. Creating rules is still very much in the human domain. Why do I think so? Humans are free to decide what to do and what not. These decisions do not have to be based on past learnings or rules. We can invent something completely new and unproven. When we decide, we say yes to some things and no to others, and so create a strategy for the future. Good strategies contains lots of no's, by the way, because no is the most valuable word, as shown in video number 306. A highly recommended watch. The ability to create rules is very much related to freedom and therefore directly connected to the responsibility to live with the consequences. Definitely not possible for current AI systems because they generally have no physical representation and do not feel the consequences. But enough philosophy. We know now that AI has to be trained and is good at executing rules found during training. The training, by the way, consumes much more energy and effort. Inference or execution is much easier. We will later see how we can offload this effort to make it compatible even with microcontrollers. If we talk about AI, we have to compare it with conventional programming and automation, because also here systems are trained and execute rules. In the traditional world, training is called programming, but the boundaries between programmed and trained rules are blurry. Complex programs can behave similarly to artificial intelligence. Try to rent a car or book a flight, for example. For the last 20 years, their pricing systems have behaved like AI. If you ask them 5 times for a price, you get different answers. Still, they are programmed with conventional programming languages. Programming languages are highly rules-based, much more than spoken languages. So their rules should be much easier to be trained or learned. Learning Python is much easier than learning Arabic, for example. Even assembler was easier. So it is a home run for AI. This leads me to 2 conclusions. The job of programming can easily be replaced by AI. Because conventional programs written in a computer language also execute rules, they can be replaced by AI that executes the same or similar rules. The only difference, AI is trained and discovers the rules automatically, while in conventional programming, humans have to find rules and program them. Let's stick with the first point. If AI can do programming, what does this mean for me as a programmer? Will I be replaced? Yes and no. Yes, for the programming part. AI is becoming a new version of what we currently call compilers. The programming language is probably called prompting instead of C++ or Python. And future compilers contain lots of AI. In this case, executing the rules is still done by a conventional program where all the rules of traditional IT management apply. This is already happening now. I usually program my ESP32s together with ChatGPT. Because regular compilers are not trained and have no simple rule of thumb knowledge, your job as a programmer is to use what you learned to create programs. You are prompted by specifications or requirements documents. AI, on the other hand, is trained and has a lot of knowledge. So, if your current job is to transfer specifications into programs, AI is a competitor and you must pay attention. Writing the specifications is much more in the domain of creating rules and, as we learned before, will stay in the hands of humans for some time to come. However, creating rules requires other skills on higher abstraction layers and involve decision-making, strategic work, and sometimes even organizational power. This is the way out for some current programmers, but not for all. The second point is much different. It has lots of potential. Just imagine that you train your AI with all companies' past transactions. Based on this training, it should be able to find the existing rules and execute them in the future without one line of conventional code. An example of such a prompt could be: deliver the product XYZ to customer A, the same way we did in the past. A massive saving for implementation projects where a lot of time is used to find existing business rules and implement them. Another prompt could be: what were the most important reasons why we missed our deadlines, sorted by relevance? Common for both topics is the importance of writing inputs for the AI. As said before, they are usually called prompts. Why must we write prompts if AI is so good at discovering rules? Because prompts have to contain the human-created rules. that must be applied in addition to the discovered ones. Otherwise, the AI would be without goals and strategies and therefore would be useless. You want an example? A prompt, "Fulfill the order as fast as possible," would lead to a different behavior than "Fulfill the order as cheap as possible." The difference is the strategy of the company issuing the prompt. However, if we replace programs written in traditional programming languages with trained AI, entirely new problems will arise. Procedural programs in conventional programming languages are predictable because you can understand their code. With the same input, they should always provide the same output. So they are easy to test. If tested, you know how they will work in the future if they are not changed. That is a huge paradigm in modern IT and the basis for many regulations. Think of ISO 9000, where the general rule is that you write everything into standard operating procedures and execute according to them. I do not know how this should be done with systems that do not behave predictably or with systems that hallucinate. A lot of work has to be done in this field before AI can be used to replace conventional programming. Self-driving cars provide a glimpse into this matter, by the way. Before we go there, we can use a combination of AI and conventional programming. You might have heard of AI agents, the buzzword of 2025. They solve problems in 2 steps. First, AI understands the issue, decides which conventional system is needed to execute the task, creates a specifications for these systems, dispatches the jobs, and pulls the results together. And second, conventional systems get queries or tasks and execute them. They are tested and respect the laws. A typical example is a chatbot in the sales department. It can answer my question: which product is best for me and when would I get it if I ordered it now? The AI asks me some qualifying questions to find out which product fits best by, for example, creating queries for the internal product database. If the customer accepts the choice, it makes a query for the ERP system to find out when the product is available, and based on this date, creates a query to the APIs of the shipping company to find out how long delivery will take and how much it will cost. Then it puts everything together and creates a proposal for the customer. Or even creates the order in the ERP system. If the customer refuses to order, it updates the CRM system with the reason the order was not placed. You see, all relevant tasks are still executed by conventional systems, just orchestrated by AI. All logistical processes are still executed according to ISO 9000, and all price calculations are done without hallucinations. This is where new frameworks like N8N, shown in my last video, fit in. It will even become possible for agents to create programs in conventional programming languages to execute tasks in current business systems. But what does this all have to do with microcontrollers? This is where the cat comes into play. I had a simple problem. Our new cat, Smokey, is used to drink from a water fountain. Yes, I know, this is a first world problem. And no, he did not learn it at our house. He came as an adult to us. So I purchased this fountain with a pump and a PIR sensor. It works okay and he is happy. However, because the fountain is in our kitchen, the pump also runs when somebody else is around. Not good. As usual on this channel, we want more. I wanted the pump to be only on when Smokey was around to drink. You see, you still need a human for such crazy ideas. What are typical solutions? Let's check if we were right with our judgment from before and ask ChatGPT. The currently most sophisticated O1 model pretends to think and proposes 6 variants. Some are better, like the RFID or load cell proposals, and others are useless, like the one with a timer. In common, all are based on proven technologies, as expected from a trained system. The last one is the one I have in mind. ChatGPT proposes using TensorFlow to detect the cat. Maybe this is possible, but I do not want to go this route because my rule of thumb says that these small AI systems are not good enough. I have something bigger but simpler in mind. ChatGPT does not mention it because it is an innovation. I want to use what we discussed before. Use one of the most advanced IA systems for cat detection and standard technology for execution. What does it look like? I power an ESP32 CAM board using the PIR sensor. As soon as something is detected, it is powered up and shoots a picture from the area around the fountain. This picture, together with the question, "Do you see a cat? Please answer with yes or no," is transferred to the API of ChatGPT, and only if the answer is yes, the pump is triggered. There is no need to train systems or spend much money on fast hardware. One API call costs much less than a cent. So my $10 budget should work for a long time. Of course, I could have solved the problem in other ways, but most of them would be less good at recognizing cats or would need expensive hardware. The best thing is that if I wanted to include Giulietta, the dog of my daughter, who is here on holiday, I simply could extend the question with "or a dog," and everything else would stay the same. You can use the same setup for other things, like the detection of humans or the postman with a parcel in his hands. Always the same code, just another question or prompt. Cool. For debugging, I suggest changing the question to "What do you see in the picture?" and being astonished by ChatGPT's responses. Then you would see if the postwoman with a parcel can be detected or if you need a better camera or camera position. This also can help with formulating the correct prompt of the final program. The code, by the way, was developed together with ChatGPT. However, because the API used for the project is relatively new, ChatGPT did not know it and I had to write this part. What are your plans for using such technology? Placing the ESP32 cam in front of your garage? Because ChatGPT can read plates, you can open the garage door if your or your wife's car approaches, for example. Or I could try to prevent Smokey from entering the cat door if he has a mouse in his mouth. Because he likes to brag with his catch and I do not like mice in our home. What can we keep from today's video? There is a big difference between defining and finding rules. Defining rules has a lot to do with choice and therefore freedom. Such rules often appear in strategies or requirements. This is why it has to be done by humans. I doubt that AI will replace us in this area soon. Because AI is trained, it is good at finding and knowing rules of thumb. If you need precision, there are better possibilities. A simple pocket calculator can do some things better than the best AI models, or at least more efficient and faster. AI systems are very good with pattern recognition. This is why they are already able to write programs, and these capabilities will grow very fast in the near future. Humans have to learn a new programming language called prompting as an input for these systems. The inference part of AI systems is very good in executing rules. This is why they could entirely replace conventional programs and execute rules trained from past transactions. Testing of such systems will be a significant issue because these systems are not as predictable as conventional programs and sometimes even hallucinate. The blended agent approach seems to be the way to go for the near future. AI is used to feed conventional or existing systems that execute. Such an approach is more manageable than pure AI systems, but very fast to build and flexible to change. Internet-connected microcontrollers like the ESP32 are perfect companions for such an approach, because with their sensors and actuators, they can connect the AI to reality. Maybe soon an AI will write the microcontroller code to connect it to reality. Then the answer to my ChatGPT prompt would be the full code for the ESP32 CAN board that calls the API and starts the pump. ChatGPT already provided code, just not a good one. That was all for today. As always, you find all the relevant links in the description. If you found this video useful or interesting, please support the channel. Thanks for watching and see you in the next video. Bye!